Hello and welcome to another C++ tutorial. So what we're going to be taking a look at today is different ways of storing information using things called containers. So we've had a little bit of a look at containers before, but we're going to dive a lot deeper and we're going to start looking at some different types of ones and also looking at how do we decide which container we use. Because depending upon how we want to work with the data and the type of data we're storing, different containers may be more suitable. So let's dive on in. So I'm going to start at the very simplest sort of setup. So the simplest version is using a fixed length array. So something like a fixed length array, which the approach for this is similar, but not quite the same as you might have seen from, for example, in C#, if you're familiar with that. So in C#, we would write, int, we put the brackets there, and then we would have integer array. And then we might, say that that's a new array that can hold 5. But in C++, that's not how we actually do this. So what we would generally do is we would put int star. So we'll dive into a little bit more the meaning of the asterisk there at a later point. But for now, what we've done is we've created a variable that is indicating, that's pointing to where that array of integers is stored. And we've said that that's going to have a length of 5. So similar to in C#, arrays are zero-based. So I could put values into this and I could say, okay, well, the first value, we might make that 100. The second value, I might make that 101. And I'm intentionally not going to initialize the other values. Now, for outputting this, well, okay, can we get the actual size of it? So let's find out. So as a test, I'm going to output whatever I get from doing size of integer array. And this is the thing, don't be afraid to experiment and try out different things. If it's a case like, okay, I think this might work, but I'm not sure, just write the code, especially if it's something quick to write and test. Just write it and find out. It's a really good approach. So experimenting with the code is a good sort of setup. So we can see that's given me back 8. So that's actually not going to be correct. What it has given me back there is the size of that pointer, that variable there. So because I'm running 64-bit program, so it's giving me a size of 8 there. Whereas if I did something like size of int, which is the size of the actual individual elements of it, this is going to typically be 4. Not always. That is something that can vary from platform to platform. So, okay, we can't do like of that. So this is thing with fixed length arrays like this. They're a bit more limited. I have to actually do something where, okay, for example, index is less than, and I can't do anything with integer array, so I have to do less than 5. And then I would be able to output the individual values. So I then could go and say, okay, integer array, index, and we'll just put a space after it, and then I'll put a new line at the end here. So, okay, I know what 2 of the values will be. What will the other values be though? Because I haven't actually set them. So we can see it's complaining because I haven't initialized index. So always look out for ones like of that. So I can see I've got 2 values, and then I've got these are filled with the same value. Now this is a really important thing. I have initialized, I have given a value to the first 2 elements. I have not initialized the remaining values. Now, when you are running the code, generally like a debug build or in particular when you're running your code from within Visual Studio. Visual Studio, when you allocate a block of memory, will actually fill it with a set pattern. So it fills it with a very specific set pattern so that if something goes wrong, you can tell, okay, I've tried to access uninitialized memory. Now, that happens when we're in Visual Studio. If I was running this program outside of Visual Studio, that isn't what would happen. So running a release version, essentially a shipped version of this, what that memory will be equal to is completely random. So it's possible to miss these problems during development because, I could be doing stuff then with, the later values in the array that aren't initialized. And so in development, it might just work because the value it happens to fill with might just be exactly right to have things work. But that's why we want to be really cautious with it. So making sure we're testing shipping builds regularly, but also just being really cautious to make sure we actually initialize everything is really important. And I'm going to do that actually all on the same line. This is a very valid way of doing things when you've got to set multiple things to the same value. So I can do that. Now the other thing, I have allocated memory here. Now if you've come from C#, you would be used to this approach where, okay, I allocate memory and that's it. You don't generally have to ever be doing anything to destroy it, because in C#, there is a thing called a garbage collector. So a garbage collector identifies something that's no longer being used and cleans it up. With C++, there isn't one available by default. You can set one up, so it's possible to create one, and things, your game engines like Unreal, things like that are based around C++, those will have their own versions of garbage collectors, so it's possible to set ones up, but by default we don't have one. So that memory doesn't get freed. Now the operating system, when our program exits, will generally be able to clean it up, but to make sure that it's gotten rid of, I'm going to do delete integer array down here. So what I'm doing is allocate memory for the array, free the memory for the array. So just really important to make sure that I do that. So okay, fixed length arrays can be pretty handy, but we do have the limitation where we don't have an easy way for getting the size for them. We can't add stuff to it. To add a new thing to it, it actually has to destroy the array, create a new larger one, and transfer everything over. An advantage with them, however, is we can access any particular element. So a fixed array is a random access container. We can access any specific index immediately. We can directly go to that. And the reason we can do that is because if we looked at that array in memory, everything is what we'd refer to as contiguous. So the first entry is at one point in memory, immediately next to it is the next entry, and then the next, and then the next. And that can be really advantageous. If you have calculations that need to run on multiple sets of data, and those are closely located in memory, that means that the chunk of memory that you're working on will be in the processor, the CPU's cache. And it means that it can process potentially everything in the array without going and fetching new stuff from memory. It's just all working in the cache, which is a lot faster. So using an array that keeps things in a contiguous area can have significant performance benefits with things like that. So that's why we might organize stuff in that way. The downside is it's slower to insert things into it, or to remove things from it. Changing that size is a slower operation. So, okay, that's pretty good. Now, this also need to remember, because I'm deleting an array, we have to go and delete like that. Okay, so what if I want the advantages of a fixed array in terms of the performance, but I want to be able to actually more easily add and remove things, and I want to be able to get the size? That's where vector comes in. So I'll bring in vector. So a vector is largely a wrapper around a fixed length array. So everything is contiguous in memory, which is great. Makes it easy for us being able to work with it very rapidly. But that also means it's more expensive for adding and removing. But it is also something that it's easier for us to operate with. So I could set up a standard vector, and this could be a standard vector of integers. So this would be an integer vector. And then to add things into it, I can just go, okay, well, integer vector, push back. And again, let's put in a couple of values into this. So the size of this will always be based upon the things that I've actually inserted into it. Now, I can actually tell it to reserve some space. So this is a really handy thing with it. So I can go, okay, well, integer vector, I want you to reserve. So that will reserve a chunk of space. And if you're going to be doing a lot of pushbacks into a vector, doing a reserve is a good approach. That's going to allocate the memory first, which is going to give you a bit of saving. Doing lots of pushbacks without having done a reserve actually can be really terrible for performance because you're doing lots of small allocations. Now, the vector is usually pretty smart in that when you are doing a pushback, if it has to increase size, usually allocates a little bit more, but something where we don't want to necessarily rely on that. So using a reserve can be really handy in that case. Now, we can iterate over this in a bit of an easier way. So we can use our ranged for loop. And then I can pretty easily just output the values from that. So that's one big advantage with the vector. We get an easier way of iterating over it, which is great. So we can just output that. So we've got that all on a new line. So we can run that. And we can see we get the values output. So that's good. We've got an easier way of working with them. So vectors, generally, there's not a lot of cases where I would use a fixed length array. In most cases, I would generally use a vector because with the vector, it makes it very easy to, if I needed to change the type of that container for some reason. The other big thing is with a vector, I get all of the performance benefits of a fixed length array. Contiguous in memory, random access, all of that I gain from using a vector, but with the added benefits of I can easily get the size, I can more easily iterate through it using cleaner syntax, and it's also got more safety checks there, which is good. So a vector, if I tried to access, say 3, if I tried to do that, I will actually get a very specific error for it that's telling me the vector subscript is out of range. So I actually get a very specific exception, which is great. That's what we want. If I tried to do this with the array, so let's access value 5, which will be invalid. Let's just try to do that. So I get a different one here, and it's a harder one to identify because I'm getting, okay, well, heap corruption detected. So it's failing in a very different way to what I would get with the vector. So even if I tried to do an output of that, now that's even worse one because I try to do the output and it runs. It's giving me a warning that it's invalid, but it actually still runs. So whereas with a vector, even if I tried to do that, so let's do integer vector 3. So we saw writing tends to kick off more of an error, but again, reading, I get a specific exception for it. And it tells me exactly what is happening wrong with a vector, that I'm accessing an incorrect index, an incorrect subscript. So I would generally say in most scenarios you would use a vector rather than a fixed array. It's giving you the same performance, but with a lot more safety and a lot more functionality for iterating through it, which is great. So, okay, fixed array and a vector, contiguous in memory, really fast for random access, but much slower when we are adding and removing things. What if we want a container where it's really fast to add things in, and we can add things in at any point very rapidly, very cheaply? Well, we can do that, and we can do that using something called a list. Now, if you're familiar with C#, really important thing. A C++ list is not the same as a C# list. A C# list is actually closest to a C++ vector. There's really sort of important difference there, very easy to get tripped up. So, okay, let's set up our list. So we'll refer to this as a vector demonstration. So let's go for a list demonstration. So a list, we set it up same way that we set up a vector. So integer list. Now what I'll notice is there's no reserve function because there can't be with something like a list. So I do have my push functions though, but I now also have push front and push back because inserting, adding something is a very cheap operation with a list. So inserting, removing, much cheaper with a list compared to a vector. So, okay, let's push front. And I'm going to push in a few different values. 2, 3, 4. Now with a list, I can't go and say, okay, I want to access element 0. If I try and do this, it's not going to compile. So one of the limitations with a list is, so we get really rapid insertion and removal of items. What we lose for that is things are not contiguous in memory, and we can't go and access something randomly. We can't go and say, okay, give me this specific element. We have to actually get to an element by walking through the previous ones, because this list is something called a linked list. And a good way to view a linked list is if you view a length of chain, where each link in the chain is a value, is an element in that list. So to get from one point in the chain to the other, we have to actually walk from link to link to link. So it means that it's very easy for us adding things in because we just, quickly break the chain, insert a new link, done. So it's very quick to access, very quick to insert things, but much slower for getting there and traversing. And things aren't contiguous in memory. That's an important thing. They will not be contiguous in memory. Now, we can still use our ranged for loop. So we can still do this exact setup. So that exact loop, but just accessing a different container, will work. So if I run that, then we can see the values appear. So that's handy. And I could also insert values at a particular point. So integer list, I could insert. Now, when I go to insert, it wants this thing called an iterator. So an iterator is a particular type of variable used for keeping track of where you are at in a container. So I can get an iterator for the beginning of the list. So I can go list.begin, and that would insert it at that point. Or I could go begin +1, and I'm going to insert the value of 10 there. So you can see, okay, well, it doesn't like +1, but ++ it will work. So with a vector, let's take a look at it. If I did an insert, I could do integer vector begin +1 and a value of 10. So this is another difference. Again, because we are able to support random access with a vector, we can just add any value here. That's completely fine. With a list, we can do ++ and we can do -. So we can increment or decrement the iterator. We can't just go and jump to a specific value because it doesn't support that. So with our iterator, if we wanted to jump 10 ahead, we would actually need to be adding to that multiple times. But this should insert that value. So we can see our vector had inserted it. We can see with this, it did begin, but it actually put it right at the very beginning. And that's because there is a difference between doing ++ before versus after. So we run it now, you can see it's in the middle. So ++ before something adds to it, so it increments it, and then the value in place, the value that it evaluates to, is that updated value. So it's called a pre-increment. If you put the ++ after, then it updates it. So it does increment it, but it returns the previous value. So it's called a post-increment. So we can insert things like this. Removal works the same way as well. So if I wanted to remove, I could remove a particular value. So it could search and remove particular ones. So we've got different options of what we can do there. So, okay, that's for a list. We can traverse through it. And the main difference with a list is it's very quick for inserting things, but it's not going to be contiguous in memory. So if you're doing a lot of looping over the data and a lot of calculations on the data, so if you're doing more of that and that's a constant heavy operation, a lot of memory access, but you're not adding and removing things a lot, then I would be using a vector. If you're doing a lot of adding and removing, then probably look at using a list. Especially if the amount is changing a lot, I would look more at using a list in that case. So, okay, that's good. We've got ones for storing single values. What if we wanted to store something where it's a bit more of a lookup? So if you're familiar with C#, you've seen dictionaries. They're what's called an associative container. So you have a container where you have keys, and each key can have an associated value. So we have a container like that in C++, something called a map. So again, I need to include map. And the setup for it is quite similar in terms of what we do. So again, standard map. Now I provide it with two types here. The first type is the key, and the second type is the value. So our keys, well, I want to bring strings into this. So I'm going to include string. So I'm going to have a map from a standard string to an integer. And this might be a price list. So then to add things into that, well, I can insert and add things in a few different ways. So let's go and try what we're familiar with from C#. Okay, well, price list, and let's say an apple is 3. We're not getting any errors, so that's good. So price list, let's go an orange, it can be 2. And then let's try a final one, because we did see there was an insert one there. So we can see we've got insert. So that we've got a few different overloads for it. And this is not unusual that you've got a lot of different things that you can use for it. You can see that there's 10 different ones for this that allows us to insert the particular thing. So let's try and see if I can insert ones like of this. So you can see that it's not happy with. And that's because we haven't provided a matching one. What we would need to do is we can provide a standard pair, a string and an integer, like that, and then that should work okay. Now to look stuff up, I could go, okay, let's loop through first. So this is one where, okay, it gets a little bit messy for starting to write this out. So this is a case where I would use auto. Auto in C++ is very similar to var in C#. Very, very similar. It's something where at compile time, it works out the type to substitute in. So price entry in our price list. So then I'm going to output price entry, and we can see it doesn't refer to them as key and value in the pair. So the key will be first equals, and then we put price entry second, like that. So when we do a ranged for loop over a map, what we're getting here is a standard pair. So I could write that as a standard pair, etc., like that, but it starts to get quite messy. And you can imagine if we had quite complex, lengthy types here, actually gets pretty messy what you end up writing here. So it's quite common to see auto in a ranged for loop like this. Let's run it. Let's see if we see. So we've got our different ones, which is cool. But much like a dictionary in C#, one of the really powerful things is that I can just go and say, okay, well, price list, and I can just provide Apple. So we can look stuff up based upon a particular value, and we'll just output it. So a map is really handy when we need to be doing looking up of information. So that might be something where you've got like a very simple database of items. So it might be looking up a particular item. It might be something like you've got awareness information for a character. So an AI might be keeping track of, okay, well, here's, the key is the actual character object, and then the value is information like, okay, when did I last see this? Where did I last see this? So that's something that is really sort of valuable there to be setting up. So maps are really handy for a scenario like of that. Now, what if we try to access something that doesn't exist, or we have a typo? So we get no error. It will just actually fail. So if we want to know if something is in there, so what I'm going to do is prompt the user, enter a fruit. I'm going to read that in. So selected fruit, and then we'll say a standard cin into that. So I want to check if that exists. So I can go, okay, well, if price list, and okay, if we take a look and see, and this is the thing, we use the autocomplete, it can really help for finding stuff. So there's no contains like we used to in C#, but there is a find. So what I could try is, okay, well, price list dot find selected fruit, and then what that returns is an iterator. And again, this is one that gets messy in terms of, okay, this would end up looking like this. So search iterator. I usually will put iter or it just to clearly indicate that what it is. So this gets, again, messy. I would again lean towards using auto in a case like of that. But how do we tell if that's valid or not? So what we can do is we can go f search iter. Now we can't just go and there's nothing we can specifically check on it. So if we want to know if that's valid, we check that it's not equal to price list dot end. And if it is not equal to that, then we can say, okay, well, selected fruit costs, and then we provide the value, which will be search iter, and it will be second, like that. Now we'll get into why it's using what's called the indirection operator. That is something we will look at, but for now, that's just how it's going to work with the iterators, but we will dive into more of that at a later point. Otherwise, we can say no price for selected fruit. We'll just put the end of line in each of these, just so it's clear. So what we're doing here is attempt to find the fruit in the price list. So if I run this, it'll prompt me. So, okay, apple costs 3. Let's run it again. Go, nah, and has no price for it. So this is something where in those cases where you're working with an iterator, so if you've got an iterator for a container and you want to know if that iterator is valid, you just check that it's not equal to the container's .end. So .end is not a valid entry in the container. Begin is, end is not. End is actually something that if an iterator is ever equal to that, it means that the iterator is invalid, that it didn't actually find the particular thing. So, okay, we can add stuff, we can search for things, we can remove stuff as well. So you'll see with stuff like of the price list, there is an arrays where we can give it then, particular values. So you can give it the key to remove. And you can also usually give stuff iterators. With the integer list, here we have similar stuff. We can remove particular values. We do also have arrays as well with this. So you can tell it to arrays and give it a specific iterator. So I could tell it to arrays integer list dot begin. And that should remove the first entry from the integer list. As you can see, the 2 has disappeared. So what you'll find generally with the containers in C#, there is a bit of inconsistency at times with the containers. In C++, there is a lot of consistency in terms of how you do things with them. It's very, very rigorous with that. So a lot of the same functions that exist for one container will exist for another, and they will do the same thing. So insertion operators, erasing, they will usually take the same types of parameters and they work in the same way. So that actually makes it very easy at times to take something and, oh, okay, that was a list. I'm going to just change that to a vector. And most things will work. Some things won't, because like push front doesn't exist for a vector. But a lot of containers, things will just work, or at least makes it very clear and easy what needs to change. So switching container actually is not too much of a headache with C++, which is great. So dive on in and experiment with this. We've seen a lot of different things here. We've seen a lot of stuff with the different types of ones and how they work. So experiment with making some changes to this yourself. Look at, okay, what if I want to remove particular items, test doing further removing, test doing adding in a bunch of things in a loop. So you could combine stuff like, okay, I'm going to use a loop to add 10 things into each of these. That's the sort of thing that you can easily add in there. You could expand this map and have it store more things. You could have it that you get the user to enter a bunch of things and push those into the map. So you could get the user to, okay, enter the item name, cool. Now enter the price for it, and then you push that into the price list. So look at different things like of that you could do that take what we've already got and start to extend it a bit. That's a good way to start to improve your knowledge and understanding of the language. So dive on in and experiment with it. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, it really helps out, it's really appreciated. If you've got any questions, chuck in a comment below. If you're looking for the code for the project, the code is available up on GitHub. As with any of the projects, you're freely able to use that in any of your own projects, commercial and non-commercial ones. And if you are trying to find other related videos, there is a link to the video archive, which is a searchable archive of all of the videos that you can use. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below as well. But until next time,